So bubble sort. Bubble sort is basically the most brute force sorting algorithm. That is, we take each element and compare it with every other element. Like for instance, here I compare 5 with 4. Then I compare 5 with 3. Then I compare 5 with 2. Then I compare 5 with 1. And then I find out that, so this is how it was. So compare 4 with 5. Next I compare 5 with 3. Next I compare 5 with 2. Then I compare 5 with 1. So yeah. Similarly, I do the same thing for 4, and then I do the same thing for 3, and then the same thing for 2, same thing for 1, etc., etc., etc. But if we look at the mathematics, then how many combinations can we make? Since we are taking a pair, how many pairs are possible? NC2 pairs, right? Or if we go to the long way, then I have 5. So if 5 is one element, how many elements are there apart from 5? I have to compare 5 with the other n minus 1 elements. And after 5 has been sorted, after one pass, we see that the array has come to this state. And now in this case, again 4 has to be compared with how many elements? How many elements are there apart from 4? Apart from 4, there are n minus 1 elements. But we know that already 5 has been sorted and it is in its proper position, because we initially compared 5 with 4 and now we don't have to compare 4 with 5 again. So therefore, n minus 1 minus 1, because one element is already sorted. Similarly, after both 4 and 5 are sorted, the array will look like this. And now we have to compare 3 with every other element apart from 4 and 5. So therefore, that is n minus 1 minus 1 minus 1, which is n minus 1 plus n minus 2 plus n minus 3 and so on up to 1. So if we look at this, then we have the mathematical formula, which is the sum of n natural numbers is equal to n into n plus 1 by 2. Sum of n natural numbers is equal to n into n plus 1 by 2. But here it is the sum of n minus 1 natural numbers. So the sum of n minus 1 natural numbers is n, which is n minus 1, into n minus 1 plus 1 by 2, which is n into n minus 1 by 2. Oh my god. Okay. So yeah, which is basically n square minus n by 2. But if you take it in terms of the asymptotic notations, then we write it as big O of n square. In simpler terms, we write it as big O of n square because we look at the highest degree. The highest degree available here is 2, and n square is larger than n. N is nothing compared to n square. So therefore, we write big O of n square. Before only I told that NC2 combinations are possible. What is NC2? N into n minus 1 by 2, which is again big O of the same thing, big O of n square. So yeah. Now if you look at the code, since the term complexity is big O of n square, and you know that we have to compare each element with the other element, it somewhat hints toward us that it is a nested for loop. So let me write the outer for loop. And here, let me tell you a logic. The logic is that the outer for loop basically accounts, or it denotes the number of times the comparison has to be performed. Well, if you have an array with n elements, then how many times should the sorting happen? Basically, we have to sort each and every element, right? So the number of times the loop has to run is basically n, because we have to sort every element. So first we have to compare the first element with every other element, second element with every other element, third element with every other element, and etc. etc. But suppose n minus 1 elements are sorted, then you know that the last element is in its proper position only. You don't have to sort it. It will be in its proper position. Like for instance here, let's say after 5 has been sorted, the array looks like this. Then after 4 has been sorted, the array would look like this. Then after 3 has been sorted, the array would look like this. And then after 2 has been sorted, the array would look like this. So therefore, how many times did I do the outer pass? 1, 2, 3, 4. I don't have to repeat the process for the last element, because we know that when the other n minus 1 elements have been sorted, the remaining is only one element. That will be in its proper position only, because an array of size 1 is always sorted, right? So therefore the loop runs n minus 1 times. So now suppose I start with I is equal to 1 and I goes until less than or equal to n minus 1. So that is the loop runs n minus 1 times. The outer loop, I'm talking about the outer loop. So, but let's say I start with I is equal to 0. That means I is equal to 0 to I is less than or equal to n minus 2. That is, I decrease this also by 1, I decrease this also by 1. And what is the purpose of doing this? The purpose of doing is that in Java or most of the programming languages, arrays follow zero-based indexing, and it will be useful to us if we start the outer for loop with I is equal to 0, because it will be easy for us to do the indexing. So while swapping and comparing and all that. So I is equal to 0, I is less than or equal to n minus 2, I plus plus. Now if we talk about the inner for loop, J actually shows the indices where the elements have to be compared. So let's say I have any J. I always compare A of J with A of J plus 1. I compare an element with its next element, next consecutive element which is present. So it always starts from 0, because once an element has been compared, the greater element will be pushed to the last position. Hence we start from 0 and we stop until which index? If I say that we stop at n minus 1 with index, that is I write that j is less than or equal to n minus 1, that means that I should compare a of j and a of j plus 1, which is a of n minus 1 and a of n. If n minus 1 is only the last element, then where is the nth element? It doesn't have element only to compare with. It doesn't have any next element. Then what will it compare with? So therefore j has to stop at not n minus 1 but n minus 2. So n minus 1 minus 1, which is less than or equal to n minus 2. Again, there is some optimization which can be done here. That is the same logic that happened here. Initially 5 has to be, in the first pass 5 has to be compared with n minus 1 elements, but in the second pass 4 will be compared with only n minus 2 elements, because it's already compared with 5. Again why you have to compare with 5 again? So the same thing here also. After the first pass, 5 has been put in its proper position. Now 4 will be compared with 3, 4 will be compared with 2, 4 will be compared with 1, 4 doesn't have to be compared with 5 again. So therefore I write minus I here, where I indicates the number of sorts which have already occurred. Like in the first pass, 0 sorts have been occurred, which is no element in its proper position. So therefore, at least in the worst case, so no element is in its proper position. Since no element is in its proper positions, in the first loop, it will run from I. In the first pass, it will run from I is equal to 0 to I is equal to n minus 2. This is n minus 2. This is n minus 1. I have to compare 5 with 1. But in the second pass, it runs only from 0 to n minus 2 minus 1, because one sorting has already been occurred. One element is already in its proper position. You just omit that particular comparison. So that is n minus 2 minus 1, which is n minus 3. Yeah, okay. Sorry, I was just looking at something. So now the comparison will stop at this. That is 4 will be compared with 1 and it will stop. Again 4 will not be compared with 5 and so on. That's another optimization which can be done. And here this is the normal code that we write. So if this is the comparison code, if a of j is greater than a of j plus 1, then we swap. What is swap? Swap is take a temporary variable and a of j is equal to a of j plus 1, a of j plus 1 is equal to 10. Yep. That's it. And this is the curly braces.